A visitor from another star system just grazed Mars, and the world's most powerful space agencies have gone completely silent. On October 3, 2025, an object named 3I Atlas offered humanity its closest look ever at an interstellar comet, with a fleet of orbiters and rovers ready to capture history. Yet the only proof of this encounter comes from a ghostly signal teased from public data by amateur analysts. Is this a cover-up, or is the truth far more complicated? Let's explore this together. The flyby. You have to understand, this wasn't just another cosmic event, it was a rendezvous that scientists have dreamed about for decades. On October 3, 2025, the interstellar comet 3I Atlas made its closest approach, skimming just under 0.2 astronomical units, that's about 29 million kilometers from the planet Mars. To put that in perspective, that's closer than any planet ever gets to another, outside of a collision. This flyby was a moment of incredible cosmic alignment. For the first time, a visitor from another star system was set to pass directly through a region of space monitored by a dedicated fleet of advanced scientific instruments. Every major space agency with a presence at Mars, from NASA and the European Space Agency, to China's CNSA and the UAE's HOPE mission, had a front-row seat. Mission planners, like Dr. Jim Bell, the principal investigator for Perseverance's Mastcam-Z cameras, scrambled to redirect their assets. This wasn't in the original mission plan, but an opportunity like this is too valuable to ignore. The calculations were precise, the stakes were enormous, and the entire planetary science community held its breath, waiting for a flood of data from our robotic eyes at Mars. The promise of Mars. So why was this Mars flyby such a monumental deal? Because our assets there could see what Earth couldn't. As 3I Atlas approached, its position in the sky made it impossible to view with ground-based telescopes, as it was lost in the glare of the sun, but our Martian orbiters were in the perfect position. Think about what that means. NASA's Mars Reconnaissance Orbiter carries the HiRISE camera, an instrument so powerful it can spot a coffee table on the Martian surface from 300 kilometers up. In theory, HiRISE could capture images resolving the comet's nucleus or any fragments breaking off with unprecedented detail. Then you have the spectrometers. ESA's Mars Express and the Trace Gas Orbiter are equipped with instruments like Omega and Nomad, designed to detect trace amounts of gases in an atmosphere. Pointed at the comet's coma, they could have sniffed out its chemical composition, telling us if it was made of the same stuff as our comets, or something truly alien. Dr. Amy Mainzer, a leading expert on comets, has emphasized that these objects are pristine leftovers from the formation of other solar systems. Getting a direct chemical reading from 3I Atlas would be like analyzing a core sample from a planet being born light years away. A faint signal emerges. With the world's space agencies silent, the first and only evidence of the flyby came not from an official press release, but from the hard drives of two persistent citizen scientists. Enter Björn Jansson and Kevin Gill, two names legendary in the community for their meticulous processing of raw space images. Working independently, they went directly to NASA's Planetary Data System, the public archive where raw data from missions like Perseverance is posted. Within hours of the data being downlinked, they began their digital excavation. Their process was painstaking. They took dozens of long-exposure images from the Mastcam-Z camera, which were designed to look at the dark Martian sky. By aligning each image based on the background stars, and then digitally stacking them, they could amplify the faint signal of anything that moved through the frame. After methodically subtracting sensor noise and cosmic ray hits, a faint, diffuse patch of light emerged, right where 3I Atlas was predicted to be. It wasn't a spectacular photo, but it was monumental, the first and only direct confirmation that the interstellar visitor had made its historic pass. Their work stands as a testament to the power of open data. The auditable path. Alright, let's break down exactly how that faint detection was proven to be real, because, this is where science really separates itself from speculation. The process kicks off with the raw data. On October 3rd, Perseverance's Mastcam-Z instrument took 36 long exposure frames, each lasting 29 seconds. The next day, it took 40 more. So, the first step for analysts like Johnson and Gill was calibration. They retrieved matching dark frames, images taken with the lens cap on, to map out the sensor's inherent electronic noise, and subtracted it pixel by pixel. Next came flat fielding, a process that removes distortions caused by dust on the camera's optics. The most critical step was registration. Each image's star field was perfectly aligned with a projected star catalog, correcting for the rover's slight movements. Once aligned, they used a technique called sigma clipping to reject outliers like cosmic ray strikes. Finally, the cleaned frames were stacked. The result was a master image where the random noise was averaged out, leaving behind a faint but statistically significant signal, a diffuse spot of light exceeding the background noise by a factor of 5 sigma, the gold standard for a scientific detection. And, this entire workflow, with all its scripts and calibration files, was published online for anyone to replicate. Viral myths and reality checks. In the vacuum of official information, the internet did what it does best. It generated myths. The moment the faint, real detection began to circulate, so did much more dramatic, but fake, images. The most viral was a sharp, razor-thin streak of light in a single frame, from Perseverance's navigation camera. It was hailed as a naked-eye view of the interstellar comet, but the truth required a dose of orbital mechanics. Dr. Emily Lakdawala, a renowned planetary scientist and author, did what any good scientist does. She checked the numbers. Using JPL's Horizons Ephemeris tool, which can predict the position of any known object in the solar system, she plotted the streak's path and timing. The verdict was undeniable. The streak perfectly matched the speed, orientation, and sky path of Phobos, Mars's inner moon, during a long exposure. The second myth was a bright, fast-moving streak in a different Mastcam Z frame. Again, the math didn't add up. Its angular velocity was at least 10 times faster than 3I Atlas was predicted to be moving. It was likely a meteor in Mars's upper atmosphere or a simple sensor artifact. These episodes were a critical lesson in scientific literacy. Not every streak in the sky is a visitor from another star. The silent orbiters. So, where is the real data? Why the deafening silence from the orbiters? Mars Reconnaissance Orbiter, with its high-rise camera, could in theory deliver the sharpest images ever taken of an interstellar object. Its narrow field of view makes every shot a gamble, but a successful one would be revolutionary. The European Space Agency's assets, Mars Express and the Trace Gas Orbiter, offered a different promise. Their spectrometers, Omega and Nomad, aren't just for taking pictures, they're for reading chemical fingerprints. They could have detected unusual isotopic ratios or molecules that would definitively prove 3I Atlas came from a completely different type of star system. Even the UAE's HOPE and China's Tianwen-1 orbiters were poised to contribute wide-angle monitoring and spectral data. The promise was real. Dr. Candace Hansen, a veteran planetary scientist who worked on multiple Mars missions, knows the immense capability of these instruments. The fact that not a single raw frame, not even a low-resolution thumbnail, has been released is the central mystery of this event. The data almost certainly exists, locked behind a wall of institutional review and processing backlogs. The knife's edge. The silence from the space agencies probably isn't a conspiracy, it's a reflection of the brutal reality of deep space operations. Pointing a spacecraft at a tiny, fast-moving object millions of kilometers away is, well, an exercise in controlled terror. The ephemeris for 3I Atlas, its predicted position, was being updated hourly. But the orbiters can't just react in real time. The commands to turn, point, and shoot have to be programmed and sent hours or even days in advance. It's what engineers call open-loop pointing. You shoot and pray the target crosses your field of view when you scheduled it to. Then there's the deep space network, the communication lifeline to Earth. Every bit of data, from every mission at Mars, competes for limited bandwidth. A historic image from high-rise might have to wait in a queue on the orbiter's solid-state drive for days behind higher-priority engineering telemetry. A single missed DSN window, or a slight drift in the comet's predicted path, could mean the difference between a Nobel Prize-winning image and a frame filled with empty black space. This is the knife's edge of interplanetary observation. Blinded by the sun. Even if the data exists, there are two massive roadblocks preventing its release: solar geometry and calibration. As October advances, 3I Atlas is heading for superior conjunction on October 21st, a point where it'll be almost directly behind the sun from our perspective. This isn't a policy, it's physics. The sun's overwhelming radiation makes communication and observation impossible. For about 6 weeks from mid-October through early December, Earth is, well, effectively blind. This means the comet's most active phase as it nears the sun will happen while we can't watch. Meanwhile, back at JPL and other institutions, the data pipeline is a gauntlet. A raw image from space isn't like a photo from your phone. It's riddled with cosmic ray hits and sensor artifacts. The specialized software pipelines, designed by teams like Malin Space Science Systems who built Mastcam Z, are tuned for static Martian landscapes, not for faint, moving targets. Releasing an uncalibrated frame would be irresponsible, risking another wave of viral myths. The teams have to be meticulous, and that meticulous work takes time, all while a government shutdown further compounds the delays. The world waits, not for a cover-up, but for good science. The working hypothesis. Based on the limited data gathered before 3I Atlas disappeared into the sun's glare, scientists have a working hypothesis, but it's full of questions. The current theory is that 3I Atlas is a natural interstellar comet, but one with a very strange chemistry. Early spectra suggested it's rich in carbon dioxide ice, but surprisingly poor in dicarbon, the molecule that gives most of our solar system's comets their classic green coma. This points to an origin in a star system with a very different chemical makeup or temperature gradient than our own. Some of the provisional reports also hinted at a possible excess of metals like nickel in its dust, a finding that, if confirmed, would be truly bizarre and hard to explain. Dr. Stephanie Milam, an expert in comet chemistry at NASA, would be chomping at the bit for the orbiter data, as only high-resolution spectra can confirm these tantalizing hints. Without that data, the natural comet scenario remains just that. A hypothesis. The real proof is still sitting on a hard drive, waiting to be processed. What remains and what comes next? With Earth-based telescopes blinded until December, the world is watching the few assets that might catch a glimpse of 3I Atlas. The SOHO spacecraft's LASCO C3 coronagraph will be able to monitor the region around the sun. Its limiting magnitude is quite bright, around 8 or 9. So, it would only spot the comet if it has a dramatic outburst, suddenly increasing in brightness. Another long shot is ESA's JUICE spacecraft, currently on its way to Jupiter. It may have a brief window in early November to try some deep-field imaging, but the real hope lies in late November and early December. That's when Earth's orbit will finally provide a clear view again. Large ground-based observatories and a network of skilled amateur astronomers are already planning their recovery campaigns. The lesson from this entire event is clear. Our current observation capabilities have a massive blind spot. Without more deep space telescopes parked in different places, like the proposed NEO surveyor, the next interstellar visitor could fly right past us, completely unseen. The story of 3I Atlas is a cliffhanger. We have a confirmed detection, a mountain of unanswered questions, and the most important data in a generation locked away, waiting for processing. This event has exposed both the incredible power of our robotic explorers and the frustrating limitations of deep space science. Was this just a strange comet, or is it something more? The answer is coming, but for now, we wait. This is a powerful reminder that the universe still holds deep mysteries, right on our cosmic doorstep. Don't forget to like, subscribe, and hit the bell icon for more explorations into the cosmos. Thanks for watching Sci and Why. When NASA's deep space monitors detected something impossible moving through the cosmic void, engineers thought their instruments had malfunctioned. But you know, the data was undeniable. 305 objects gliding in perfect formation through interstellar space, pulsing with structured signals that just defied every law of physics. After 47 years of silent travel, humanity's most distant spacecraft had stumbled upon something that challenged our understanding of the universe itself. Today on Sci and Why, we're unveiling the discovery that has NASA scientists questioning everything they thought they knew about deep space. The lonely pioneer's greatest discovery. After nearly 5 decades drifting through the cosmic void, Voyager 1 detected something that shouldn't exist, a faint signal that would change everything we know about interstellar space. Voyager 1, launched in 1977 with technology older than most smartphones, has become humanity's most distant ambassador. Traveling over 15 billion miles from Earth, this car-sized spacecraft operates in the harsh environment of interstellar space, where our sun's influence just fades into nothingness. Originally designed to study Jupiter and Saturn for just 5 years, Voyager has defied all expectations, continuing to transmit data across the cosmic darkness. Its instruments, built with 1970s technology, include magnetometers, plasma wave sensors, and cosmic ray detectors, all now serving as our first eyes and ears beyond the solar system. The spacecraft's nuclear power source, fueled by decaying plutonium, was expected to fail decades ago, yet it continues whispering back to Earth. Each radio signal takes over 22 hours to reach us, traveling at the speed of light across the vast emptiness. When Dr. Eliza Karna first noticed the anomaly in Voyager's data stream, she described it as shouting into a canyon for decades and finally something shouts back. The signal that changed everything. What began as background noise in Voyager's data stream revealed itself to be something far more extraordinary. A deliberate signal from the depths of interstellar space. The first indication something was wrong came through Voyager's plasma wave sensors. Among the usual cosmic static, a faint but persistent signal appeared, rhythmic, structured, and completely unlike anything previously recorded. NASA's Jet Propulsion Laboratory initially dismissed it as instrument noise, but the signal's behavior just defied explanation. Unlike random cosmic radiation, this anomaly showed patterns, repetition, and what appeared to be intentional modulation. Systems analyst Carlo Romero noted that the signal's characteristics resembled the kind of deliberate motion one might expect from a drone rather than a rock. The plasma readings showed organized pulses echoing through space, creating magnetic fluctuations that seemed purposeful rather than chaotic. As engineers analyzed the data more carefully, they realized this wasn't just electromagnetic interference, it was something actively moving through the interstellar medium. The signal's strength varied in ways that suggested a physical object passing by Voyager's sensors, but its behavior patterns indicated intelligence or at least sophisticated design. The discovery triggered NASA's Level 3 Alert Protocol, reserved for phenomena that don't fit within current scientific understanding. Movement that defies physics. The object wasn't just moving through space, it was accelerating, changing direction, and gliding with precision that seemed to mock every law of physics we understand. Traditional space objects follow predictable paths governed by gravity, momentum, and known forces. But this anomaly broke every rule. Dr. Lucas Hang at JPL ran simulation after simulation, trying to match the object's behavior to known models, but nothing worked. The object curved through space with deliberate precision, accelerating without any visible propulsion system. There were no engine flares, no ion trails, no heat signatures, yet Doppler shift measurements showed it moving at incredible speeds. Some readings indicated velocities exceeding the calculated escape velocity of the entire Milky Way galaxy. The object's path bent in ways that defied orbital mechanics, with no drift or decay expected from natural phenomena. It wasn't tumbling chaotically like space debris. Instead, it maintained controlled flight patterns that suggested active guidance. The movement appeared to manipulate space itself, creating ripples in the fabric of space-time that allowed forward motion without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure. The formation revelation. When scientists pulled up the complete telemetry data, they discovered something that honestly sent chills down their spines. This wasn't just one object, but 305 moving together in perfect formation. The full scope of the discovery really emerged when engineers analyzed all available data from both Voyager spacecraft. What they found just defied comprehension. 305 distinct objects moving through interstellar space in coordinated formation. Each object maintained precise relative positions to the others, gliding past Voyager 1 in what appeared to be a choreographed arc. This wasn't debris scattered randomly through space. These objects moved as a unified group, displaying organization and purpose that seemed impossible without some form of control. In the vacuum of space, groups of objects naturally spread apart over time due to gravitational influences and velocity differences. Yet these 305 objects maintained their formation with precision that suggested active coordination. Scientists compared it to watching a flock of birds or a school of fish, except this was happening in the emptiness between stars where such coordinated movement shouldn't be possible without technology. The formation itself spanned vast distances, with objects separated by thousands of miles yet moving in perfect synchronization. Each object displayed the same unusual characteristics: structured plasma pulses, magnetic field distortions, and impossible propulsion signatures. The language of the cosmos. Hidden within the plasma waves were patterns so structured and deliberate that scientists began to wonder if they were witnessing the universe's first attempt to communicate with humanity. As researchers examined the signals more closely, they discovered something that just transformed the entire investigation. The plasma wave pulses weren't random electromagnetic noise, they contained loops, sequences, and structures that resembled communication protocols. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals showed rhythmic repetition, harmonic intervals, and organized sequences that suggested encoded information. These weren't the chaotic bursts expected from cosmic phenomena, but measured, deliberate transmissions that seemed designed to convey meaning. The waveforms resembled quantum oscillations used in modern entanglement experiments, the same signals researchers use to transmit information between particles separated by vast distances. Each of the 305 objects contributed to this cosmic symphony, broadcasting synchronized pulses that created complex interference patterns in the interstellar medium. The mathematical precision of these signals suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorize that the objects were using the vacuum of space itself as a communication medium, encoding data in the fabric of space-time. Earth's unexpected reception. While NASA analyzed Voyager's data, amateur radio operators across Earth began detecting the same mysterious signals, proving this phenomenon was far more powerful than anyone imagined. As Voyager transmitted its extraordinary findings back to Earth, something unexpected happened in radio stations worldwide. Amateur operators with backyard setups began reporting strange activity, weak, irregular pulses that didn't match any known terrestrial source. These weren't professional observatories or official deep space monitoring stations, but hobbyists with spare parts equipment designed to catch meteor scatter and satellite chatter. Yet somehow, they were detecting faint echoes of the same signals Voyager had recorded billions of miles away. The timing was impossible to ignore. These Earth-based detections aligned perfectly with Voyager's most intense plasma anomalies. The signals weren't strong, but they showed the same patterns and regularity that had puzzled NASA scientists. Some operators described them as ripples reflecting off invisible walls in the ionosphere, while others noted their unusual harmonic structure. The phenomenon suggested that whatever was generating these signals possessed incredible power, capable of transmitting across interstellar distances with enough strength to leak into Earth's electromagnetic spectrum. This raised troubling questions about intentionality. Was this accidental bleed-through, or was something deliberately testing Earth's listening capabilities? The historical search. Desperate for answers, NASA scientists combed through 50 years of space mission data, searching for any previous encounter with these mysterious objects, and, well, they found absolutely nothing. With mounting evidence of something unprecedented happening out there in deep space, a specialized team began examining decades of archived mission data. They searched through every deep space mission on record, Pioneer 10, Pioneer 11, New Horizons, and, countless others, looking for any hint that similar phenomena had occurred before. The investigation took them into these dusty archives containing records that hadn't been touched since the 1980s, analyzing data that had often been dismissed as background noise or just instrument error. If these 305 objects had passed through our region of space before, there should have been traces in the historical record. But the search yielded nothing. No echoes, no formations, no plasma loops in any previous mission data resembled what Voyager was currently detecting. This absence of historical precedent made the current situation even more extraordinary. The objects weren't part of a repeating cycle or a known phenomenon. They were either entirely new or had somehow remained invisible to our instruments until now. Some researchers even proposed a chilling theory. Maybe these objects had always been present but cloaked or dormant, activated only by Voyager's presence or perhaps its golden record transmission. The machine's transformation. As if the discovery wasn't strange enough, Voyager itself began changing, reconfiguring its systems in ways engineers never programmed. almost as if something had awakened within the ancient spacecraft. While scientists grappled with the implications of the 305 objects, Voyager 1 itself started exhibiting unprecedented behavior. The spacecraft's attitude and articulation control system began routing data through old, long unused subsystems, bypassing its core software in ways that seemed almost deliberate. Engineers initially suspected a malfunction. After all, this was 47-year-old technology running on code older than most of the people analyzing it. But deeper investigation revealed something more unsettling. Voyager wasn't failing, it was reconfiguring itself. The spacecraft began reactivating memory segments that hadn't been accessed in decades, rerouting telemetry through pathways that were never part of its original programming. This behavior started immediately after one of the strongest magnetic pulses from the passing objects, suggesting a possible connection between the external phenomenon and Voyager's internal changes. The modifications were too systematic and clean to be random corruption. They appeared purposeful, as if the spacecraft was adapting to new circumstances. Engineers had to dig through dusty file cabinets at JPL, consulting 1970s paper manuals and assembly language code to understand what was happening. The quantum connection. Deep within Voyager's data streams, scientists discovered something that changed everything. The mysterious signals were using quantum entanglement principles to transmit information across impossible distances. As analysis of the plasma wave data continued, researchers made a discovery that revolutionized their understanding of the phenomenon. The structured signals weren't just organized, they exhibited characteristics of quantum entanglement, the same principles used in cutting-edge Earth-based communication experiments. The waveforms showed quantum oscillations that suggested the 305 objects were using the interstellar medium itself as a transmission network, encoding information in the fabric of space-time. This revelation opened the possibility that Voyager hadn't just stumbled upon random objects, but had intercepted part of a vast communication system spanning the galaxy. The spacecraft's analog sensors, free from the electromagnetic noise of modern digital systems, made it the perfect receiver for these quantum transmissions. Being positioned far beyond the solar system's interference, Voyager existed in an ideal listening environment, a cosmic microphone in the perfect acoustic chamber. The signals showed harmonic intervals and mathematical precision that suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were part of an ancient network, a galactic internet that had been operating for millennia undetected by human technology. The cosmic network awakens. As Voyager continues its journey through the darkness, scientists realize it may have become part of something far greater, a galactic communication network that has been waiting for humanity to finally listen. The implications of Voyager's discovery extend far beyond a simple encounter with unknown objects. Evidence suggests the spacecraft has stumbled upon, or been deliberately included in, a vast communication network that spans the galaxy. The 305 objects appear to be nodes in this system, relay stations that maintain and transmit information across interstellar distances using quantum entanglement principles. Voyager's transformation, its spontaneous reconfiguration and activation of dormant systems, might represent integration into this network, turning humanity's oldest space traveler into our first interstellar communication terminal. The structured nature of the signals, their quantum characteristics, and their perfect timing suggest this isn't a random encounter, but a deliberate contact event. Perhaps the network has been monitoring our technological development, waiting for the right moment when we possess the capability to detect and understand its transmissions. Voyager's analog design, its position beyond solar interference, and its decades of faithful service made it the ideal candidate for first contact. The spacecraft's golden record, carrying sounds and images from Earth, might have served as our credentials, proof that humanity was ready to join a larger galactic community. Voyager 1's discovery of 305 mysterious objects moving in formation through deep space represents either the greatest natural phenomenon ever recorded or humanity's first confirmed contact with non-human intelligence. As our brave little spacecraft continues its journey into the cosmic unknown, it carries with it the hopes of an entire species, and possibly our first invitation to join a galactic community. If you're fascinated by these incredible cosmic mysteries, Hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending space discoveries. Thanks for watching. Keep exploring the infinite. What if a comet entered our solar system and broke every rule we thought we knew? Imagine an object that defies the fundamental laws of physics, sporting a feature that looks less like nature and more like engineering. This isn't science fiction. It's a thought experiment grounded in a torrent of strange data from real interstellar visitors. We're about to explore a hypothetical scenario based on real science that pushes the boundaries of understanding. Let's delve into it together. The Chilean frame. It all starts with a single unexpected image. Imagine an amateur astronomer, much like the legendary Gennady Borisov, who discovered the first confirmed interstellar comet from his backyard Margo Observatory, peering at the sky from the clear darkness of Chile's Atacama Desert. The date is October 20th, 2025. Her equipment, a 150mm refractor, is pointed at the coordinates for a newly tracked interstellar object, 3I Atlas. What comes back from her cooled CMOS camera after a 60-second exposure isn't a textbook comet. The raw data, captured under pristine verifiable conditions with atmospheric seeing logged at an exceptional 0.7 arcseconds, shows something impossible. This isn't a blurry social media rumor, it's a hard data point from a credible observer. The coordinates match NASA's official Jet Propulsion Laboratory tracking. The equipment metadata is clean, and the image is perfectly sharp. And there, aimed directly at the sun, is a perfectly straight, highly collimated jet of material. This single frame from a small converted farm building becomes the most important astronomical image of the decade, kicking off a firestorm of debate and challenging the very foundation of cometary science. Comet Physics 101. So, why is a sunward-pointing jet such a big deal? First, let's cover the basics. Comets are often called cosmic snowballs, a term coined by the brilliant astronomer Fred Whipple back in 1950. His model describes a nucleus made of ice, dust, and rock. As a comet approaches the sun, solar radiation heats its surface, causing ices like water to turn directly into gas, a process called sublimation, at temperatures above -100 degrees Fahrenheit. This process creates a glowing atmosphere around the nucleus called a coma. The sun's influence doesn't stop there. It produces two distinct forces: radiation pressure from photons and the solar wind, a stream of charged particles traveling at over 400 kilometers per second. As explained by solar physicist Eugene Parker, these forces push the gas and dust away, forming two tails. The dust tail is broad and curved. The ion tail, made of charged gas, is thinner and points directly away from the sun, like a windsock in a gale. No matter where the comet is in its orbit, the rule is unwavering. The tails always point away from the sun. This is fundamental observable physics, seen in every comet we've ever studied. The sunward jet. Now, let's go back to that Chilean frame. It throws the rulebook out the window. Instead of a fuzzy coma and majestic tails pointing away from the solar glare, the image of 3I Atlas shows something entirely different. The nucleus is a sharp, dark point. The surrounding coma is strangely faint, with a measured magnitude of only 18.5, far dimmer than expected. But the most shocking feature is a narrow, focused column of material, no more than 2 arcseconds wide, extending from the nucleus directly toward the sun. It's not a tail, it's a jet. Seasoned comet observers, like the renowned planetary scientist David Jewett, would find this image deeply unsettling. The expected anti-solar tail is completely missing, replaced by a feature that seems to violate the basic principles of solar-driven outgassing. The object is actively resisting a 400 km/s solar wind. The image confronts us with a stark contradiction. An object that should be fleeing the sun's power appears to be pointing something straight at it. This single observation demands an explanation, and the easy answers simply don't hold up. Breaking the rules. Let's be clear about how profoundly this hypothetical image breaks the standard cometary model. The physics of solar sublimation dictates that as a comet gets closer to the sun, it should become more active, the coma should brighten, and the tails should grow longer. Under the excellent viewing conditions logged in Chile, a normal comet at this distance would be expected to brighten by at least a full magnitude, displaying a luminous coma and a clearly visible tail. Yet, 3I Atlas shows a minimal coma, and its only significant feature is a jet running in the completely wrong direction. Scientists like Imre Toth, who specialize in comet activity, would immediately suspect an equipment malfunction. Could it be an artifact, like a sensor streak? The data suggests no. The feature is too sharp, too perfectly aligned with the sun's position, and it persists across multiple, independent processing attempts of the raw data. It's too regular to be random noise. We are left with a data point that suggests the rules of sublimation and solar pressure are, for some reason, not applying to this object, a conclusion no scientist would reach lightly.
The Gauntlet.
Every extraordinary claim in astronomy must survive a gauntlet of mundane explanations. The first suspect is always geometry. Sometimes, from Earth's specific vantage point, dust left in a comet's orbit can create an anti-tail. However, anti-tails, studied extensively by scientists like Michael S. P. Kelly during NASA's EPOXY mission, only appear when Earth crosses the comet's orbital plane. On October 20th, Earth was still over 4 degrees away from the orbital plane of 3I Atlas, making a prominent anti-tail highly improbable. More importantly, anti-tails are always broad, diffuse sheets of dust, not the tightly focused jet seen in the image. The next suspect is a transient event, like a pocket of volatile ice erupting. But these outbursts are chaotic and short-lived, rarely lasting more than a few rotations of the nucleus. The sun-facing feature in the Atlas data is persistent across more than 4 hours of observation, making a fleeting eruption unlikely. Finally, atmospheric distortion is ruled out by the observatory's logs. The stars in the image are sharp, proving the sky was stable. After running the checklist, every conventional explanation falls short of explaining the hard data.
Chemical anomalies.
The weirdness isn't just visual. Spectroscopic analysis of 3I Atlas reveals a chemical composition that is bizarre, even for an interstellar traveler. The data shows a carbon dioxide to water ratio of nearly 8:1, one of the highest ever recorded. For comparison, the famously CO2-rich Comet C 2016 R2 Pan-STARRS had a ratio of about 5:1. This tells us 3I Atlas was formed in a place far different from our own solar system's water-rich environment. But the real smoking gun is the metal content. Preliminary spectra from observatories like the Keck telescope hint at the presence of nickel emission lines, but with a strange absence of iron. In all typical cometary material, iron is at least 10 times more abundant than nickel. The data from 3I Atlas suggests a nickel-rich, iron-poor outflow, a pattern with no known natural precedent. Scientists like Denis Bodowitz, who studied the chemistry of 2I Borisov, would be stunned by these readings. The unique chemistry suggests a nucleus with properties we've never encountered, deepening the mystery of the sunward jet.
Retrograde path.
The object's path through our solar system is another major red flag. 3I Atlas is on a retrograde orbit, with an inclination of 110 degrees, meaning it's traveling against the flow of planetary traffic. Its immense speed, with a hyperbolic excess velocity measured at 32 kilometers per second, absolutely confirms its interstellar origin. It's a tourist here, not a resident, but its trajectory, combined with its estimated mass, raises fascinating questions. When scientists like Avi Loeb analyzed the first interstellar object, Oumuamua, its slight deviation in trajectory led to the hypothesis that it could be an artificial object, a solar sail. Now, with 3I Atlas, we have a different anomaly. It's not a subtle acceleration, it's a visible, persistent structure that seems to defy solar forces. This sun-facing jet, in the context of its exotic composition and retrograde path, forces us to consider possibilities that stretch natural explanations to their breaking point. Could this jet be a functional feature perhaps, as propulsion expert Mason Peck has theorized in other contexts, an engineered structure for orbital maneuvering?
Perihelion blindness.
Here's where the timing gets critical. The comet is scheduled to reach perihelion, its closest approach to the Sun, at a distance of 0.4 astronomical units, on October 29th. At that exact moment it will be hidden from our view, positioned directly behind the Sun in a solar conjunction. This creates a week-long observational blackout for all ground-based telescopes on Earth. Any sudden change in behavior, a fragmentation, a course correction, or a massive energy release, could happen completely undetected. During this period, our only eyes on the comet belong to a handful of space-based instruments. The SOHO Observatory's coronagraph can spot large-scale outbursts, while the Parker Solar Probe might record changes in brightness. But the data will be patchy and delayed. As Noray Rawafi, the project scientist for Parker Solar Probe, knows well, these instruments are designed to study the sun, not hunt for cometary anomalies. This period of perihelion blindness is the perfect time for something extraordinary to happen, unseen by human eyes.
Space Watchers.
Once 3I Atlas emerges from behind the sun in early November, an army of telescopes will be waiting. The scientific community will be on high alert, and the checklist of what to look for is clear. First is photometry. A sudden jump in brightness could signal a natural outburst, while a steady fade without a growing tail would be highly unusual. Next is morphology. Does the comet finally grow a classic anti-solar tail? Or does the bizarre sunward jet persist? Programs like Pan-STARRS, directed by astronomers such as Ken Chambers, are designed for this kind of monitoring and can detect objects down to a magnitude of 24. They will search for any fragmentation, the appearance of smaller companion objects breaking off the main nucleus. Even tiny, almost imperceptible shifts in its trajectory, measured with a precision of milli-arcseconds, will be meticulously tracked by professional networks. Every new piece of data will be scrutinized, compared, and debated by experts like comet dynamicist David Nesvorny. The weeks following the solar conjunction will be a critical test for all existing theories.
Emergence.
As the first post-perihelion images arrive, the scientific process will kick into high gear. Interpreting the new data will demand extreme caution. Image processing techniques, how you stack frames or subtract background light, can easily create or hide faint features. A jet that is visible in one astronomer's processed image might vanish in another's. The key, as always, will be reproducibility and peer review. As emphasized by researchers like Michelle Bannister, a claim is only as good as the independent evidence that supports it. No single image will be enough. The global astronomy community will need to achieve a high signal-to-noise ratio, ideally greater than 5, across multiple independent datasets to confirm any anomalous feature. Only a structure that appears consistently can be considered real. The story of 3I Atlas will ultimately be written not by a single dramatic snapshot, but by the slow, careful, and rigorous work of scientists checking, rechecking, and challenging each other's findings. The truth will be found in the consensus of global data. So, we are left standing at a precipice. A hypothetical object, 3I Atlas, backed by puzzling data from real interstellar visitors, forces us to confront the limits of our knowledge. Is its sunward jet a fleeting natural phenomenon, a sign of exotic chemistry we've never seen before? Or is it something that fundamentally bends the rules of physics, hinting at a purpose beyond natural formation? The period of perihelion blindness leaves us in suspense, but the weeks that follow promise a flood of new data. The answers are waiting out there, in the cold dark of space. What do you think is happening with this object? Let us know in the comments below, and don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Sci and Why.